Hi everyone. So hopefully you have already watched the graphing reciprocal function notes, and then now you're watching key features of reciprocal function notes before you're about to attempt the worksheet. So this is the key features of reciprocal functions notes, and I just wanted to go over with you guys of kind of how to find everything algebraically and stuff like that, because I know the exploring activity was just kind of like looking if there was an actual point or not on your x and y intercept. So I want to show you how to algebraically actually find this stuff. So let's go over on how to graph. We want to first always start off with your asymptotes. We see that we have a value down here, which means that we are going to have our vertical asymptote at x equals -2. Always the opposite again. I don't have anything on the outside there, so I just have a horizontal asymptote at y equals 0. Okay, so then now for our actual graph, let's go ahead and do our asymptotes here. So at x equals -2, I have a vertical line, dotted line going through that point at -2, and then at y equals 0. So again, this shows that my origin is going to start right here, and I'm going to use my graph of going up one to the right one. And then even if I went to the right one, up one, I still end up at the same point, or even down one to the left one, I end up over here. So we're going to go ahead and extend those graphs there, and then we see that we have our actual graph. So now we can actually go through and start finding our actual characteristics or our key features of our graph here. So for the y-intercept, that's always when x equals 0. So if we actually go through and solve this, we see that we have y. We're going to plug in 0 into our actual equation over here. So 1 divided by 0 plus 2, well, perfect. Well, we have y equals 1/2. So we write that as a point. So we plugged in 0 for x, and then we got 1/2 out for y. Now we're going to find our x-intercept. We want to see where, it's okay you guys, by the way, if it doesn't actually match the graph there. We just did a general graph, so that's, I mean, we can start making it more exact. So now if we were to have like a half there, it would actually come down here more. So we're at the halfway mark, okay? So then now our x-intercept is when y equals 0. So now we're going to try and solve for x. So right now, I need to get out of a fraction, so I'm going to multiply both sides by the x plus 2, x plus 2. In this case, this is nice. I don't have to actually, because 0 times x plus 2 is actually just 0, and I don't have to actually distribute this number. If I had a number right here, I'd have to distribute it to the x plus 2 value. But that's not, so these divide out and I get 0 equals 1. Well, 0 cannot equal 1, so we actually do not have an x-intercept. And as you can actually see, the reason why that error happens is because we actually have an asymptote there that's allowing us to not have an x-intercept. So we say NA for that situation. Okay? If we state our domain, this again we get to use, since domain is our x, we get to look at our asymptote of our x, so -infinity less than x, which is less than -2. And then we pick up where we left off at -2 less than x, which is going off to infinity. And then our range, we look at our y value, so -infinity is less than y, which is less than 0. And we pick up where we left off at 0 less than y, which is less than infinity. Always least to greatest. Okay, and then now it says to state the interval on which the graph of f is increasing. So where is our graph going up? Is it increasing? Am I able to have a little stick figure guy walk up the mountain? But he has to be going from left to right. So he would actually be decreasing here. He's decreasing, not going, he's going that direction, left to right, left to right. Again with this, if we're going left to right, he's walking this way, and this is not increasing at all. So we have NA as our interval for increasing. Now, what about when it's actually greater than 0? That means that this is above the x-axis. So we are looking to see anything that is positive or above the x-axis. So let's see what part of our graph actually is above the x-axis. Well, we get to see that it starts becoming above the x-axis so I'm going to do green now, so it's above the x-axis as soon as it starts from this asymptote. That asymptote's at -2, so our actual interval is going from -2, it's our least value, less than or equal to x, actually not even equal to because it's not touching the -2, x, and then less than, it goes off to infinity. Okay, let's try one more of these examples, you guys. Get you to be experts at this. So I don't have a vertical asymptote because I don't have anything next to that x. However, I do have a horizontal asymptote at y equals -2. So let's go ahead and actually draw our asymptotes in. So y equals -2, your dotted line here, and we are not going to be able to go past that, and then x equals 0 is our vertical asymptote here. And then we get to actually start graphing this. So up one to the right one, and even if I went to the right one, up one, I'm still at that same point. Continue your graph there. And then we also have to go in the negative direction. Negative divided negative is still a positive, so we go in that negative direction again. And then there's our graph. So the other one that's easy is let's just figure out our domain real fast. Negative infinity less than x, which is less than our x value here, which is 0. Pick up where you left off. 0 is less than x, which is less than infinity. Go to our domain. Negative infinity is less than y, which is less than. Go to your y value, -2, and then pick up where you left off at -2. Y is less than infinity. Okay, now we can go through and find our y-intercept. Y-intercept is when your x equals 0. So you're going to do 1 divided by 0. Oh, we actually see that we are not allowed to divide by 0. That is not allowed. You cannot do that. So we actually do not have a y-intercept. This is the whole reason why you guys are checking your solutions, because for the x and y-intercepts we want to see if they're actually allowed. And the reason why we don't have a y-intercept, we have this lovely asymptote at y equals 0, or sorry, x equals 0, that's showing us that we cannot even touch the axis there. It will not cross the y-axis. So then we'd go to our x-intercept. This is where we plug in 0 for y, and now we're going to solve for x. So I get 0 equals 1 divided by x minus 2. We're going to now add 2 to both sides of our equation, leaving us with 2 equals 1 over x. Now I have to multiply by both sides by x, leaving me with 2x equals 1. Go ahead and divide both sides by 2, and now I get x equals 1/2. Okay, so make sure you write that as a point. We came out with a 1/2 as our x value, and we plugged in 0 for our y value. So write that as a point. That is our x-intercept, and that's actually where our graph would more accurately be going through, so we can make sure that we start getting more accurate on those. Then our last two key features, graph of where it's decreasing, we're intervals, so we're going to be looking like our domains and ranges up there. So for our interval of where it's decreasing, is our little guy now walking downhill ever? Well, yeah, actually he is. He's going from left to right. He's walking, and this is actually increasingly getting slower, 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 infinitely smaller. So we actually get to just write our domain for the actual decreasing interval, because both graphs are actually decreasing. Okay, so we get to just rewrite your domain for your decreasing interval. Oh, not infinity, sorry, just 0. And then comma, just so we could separate it. You guys can see that there's two values that we have to write, and we go off to infinity. Now, greater than 0. Again, it's above the x-axis here, okay? So whenever it's positive, we're looking to see when it's above the x-axis. Well, we happen to know what our x-intercept is, and our x-intercept is that 1/2 value. So we see that it is actually coming from the value of 0 to that 1/2 mark. So this is that 1/2 mark, and it's everything on this left side that cannot touch that 0. So 0 is going to be our least value that can go to, and then our greatest value that is above the x-axis is the 1/2. Alright guys, that's it. Please rewatch this video as many times as you need to. Slow it down, pause it. It is a lot. You guys will be experts at it after you guys just watch these two examples. Alright, good luck.